Okay, here are the answers to Ph04 January 2013. It's questions 1 to 5. Right. Looking at number 1, the unit for magnetic flux is the, well, this is one of those ones you either know it or you don't. It's the Weber. Moving on. So this is a bit of a cheat here, isn't it? Because I've given you these questions for a test on electricity and magnetism. This is momentum, but hey, I'm sure you'll cope. Right, so looking at this one, when you read it, a body initially at rest explodes. So that immediately tells me that when it explodes, both of these masses, M1 and M2, have the same momentum. So I'm going to write that down. So the momentum of the first one and the second one, the two halves will have the same momentum. Right. If we expand that and put the equation in, so M1 V1 will equal M2 V2. And what we're after is the correct ratio of masses when the ratio of velocities is like that. So clearly, just simply rearranging the equation will lead you to this. So in this case, B will be the right answer. Moving on. Which of the following is a property of a uniform electric field? What I'm looking for here is my best answer. So a field that doesn't change over time. Well, you could change it over time. A field that acts equally in all directions. Well, it wouldn't, because if you think about perpendicular to the field, that would be different. A field that only produces a force on moving charged particles, well, again, that's not true. But a field that has the same strength at all points, that's the one. So it's D in that case. Again, moving on for question 4. So a potential difference of 50 volts is applied between two identical parallel aluminium plates, and they've got a separation of 10 millimeters. What combination of separation and potential difference will double the electric field? Well, I think to begin with, I need to calculate what electric field strength I've got to start with. So if I remember the equation, E equals V over D, and I'm just going to pop the numbers in. And at this point, because I'm just looking for it to double, I can ignore the fact that it's in millimeters. I'll put the unit in, so it's simply going to be 5 volts per millimeter. Okay, so I'm looking for something which will give me an electric field strength of 10 volts per millimeter. So if I just nip down this list, so 100 divided by 20, that's going to be 5 again. That's going to be, no, it's not going to give us what I want. But this one here is 100 divided by 10, which will give me the 10 volts per millimeter that I'm actually looking for. So in this case, it's C. And my final question there we go. Which of the following is not a vector quantity? Well, normally the correct exam technique here is to figure out which ones are vector and why they're vectors. So field strength. Well, the second equation for field strength, we've got force in it. Now that's a vector, so that makes electric field strength a vector. Magnetic flux density. Well, let's have a look. So magnetic flux density, now that's going to be a vector as well. Why would that be? Well, I guess one definition of magnetic flux density is this one. that involves force again, so that makes it a vector. Momentum, well, velocity is a vector, so the only possible answer here is potential difference.